we go to, there are only two informed search, which are star search and greedy search. The greedy search is, we also take consider the cost of path, but there's straight line distance heuristic. Okay, so the function or formula for greedy search is f of n is equals to h of n. Okay, each line distance. Okay. So in informed search example, you will be given a map, also some heuristics values. That's how you can identify what kind of search you are doing. So for this one, there are example like start node, and then okay, it goes on. So let's just start with example. This is greedy search, and this is the common Romania map. Okay, and this is another small map, and there's some heuristic values. Um, so if greedy search, okay. So for this search, the code is here. Okay, let's just plane through the code. Okay, greedy search. So similar to BFS, I have added the neighbors and the cost, and also here the new thing is heuristics values. Okay, so in greedy search we will consider not only the cost but also the heuristic values, and similar start node and node or goal node you can say. So we will call the greedy search function. We are passing the parameters graph, heuristics, start node, and end node. Okay, so it will give us the path and the cost. And now let's look at this greedy search function. What is doing here is, current node is the start node, then the path of that current node is like the array, I mean the neighbors are added here. Initially the total cost is 0, so this loop will run until current goal not equal to goal node. Okay, so neighbors graph dot get current. Okay, so what does it do is get all the neighbors of the current node. Okay, then it will check whether there's a path to, if not neighbors, like there is no neighbors, so it will just return that no path found. Okay, no path found. Okay, or the node does not exist. Otherwise it will go to the next node and take the minimum of heuristics, and after that the total cost will be increased. Total cost plus is equals to next node of 1. After that current node will be the next node. Okay, then path will be added to the, sorry, current will be added to the path. Okay, so this will continue until the current and goal node is not is equals to uh, sorry, goal is card node, until this similar this will continue. So this will if we run this code, you can see, yeah, ACIKL, that's the path, and the total cost is 85. So for this example, the path is ACIKL. Okay, ACIKL, and the total cost is 85. 85 here, like 24, 25, 18, 18. Okay, 24, 25, 18, 18. Yeah, 85. That's how it is. 85. So it's just the cost of the path, and this is the path. This is how the greedy search work. Um, After that, greedy search, there are A-star search. So for A-star search, A-star search we are only considering here the cost. Okay, the cost g of n. But here we also consider h of n. Right, we are considering the g of n only. sorry, h of n only. And here we will consider the g of n. G of n is the path cost. Okay, g of n is the path cost. Here the formula for s dash hash is g of n plus h of n. Okay, so if we do the calculation for this one, this is the Romania map. So let's say we are initial node is Arad and we want to go to Bucharest. Okay, Bucharest. So this is our goal node. So let's start at Arad. So for the function f of Arad, the formula is g of Arad plus h of Arad. So g of Arad, Arad to Arad cost is 0. That's why 0. And h of Arad is 36. It's given here. Okay, on the right side. So f of Arad will be 3366. Next we will explore Arad. Neighbors of Arad are what is Zarind and Timis Timis something I don't know, and Siblu. Okay, so Timisora. Okay, so we if we explore Zarin, g of Zarin will be 0 plus 75, which is 75, and f of Zarin will be 75 plus 374, like a g of uh, Zarin is 75. Now here g of the function is like f of g of Zarin plus h of Zarin. So h of Zarin is given here. Yeah, 374, and the cost is 75. Okay, 75. Arad to Zerin cost is 75 and heuristic cost is 374. So here total 449. So next is Siblu. So Arad to Siblu is 140 and the heuristic cost of here 253. So the total is 140 plus 253, 393. After that, in Sora, the cost is 118 and the heuristic cost is 329. So the total is 447. Now, what's the minimum of all this? 399, 393. So we will explore Cebu. Okay, explore Cebu. So while exploring Cebu, there are two neighbors, Fagaras and Riminco. Okay, so the cost to Riminco is 80 and the Fagaras is 99. So let's just Cebu. Oh, there's another is Ordia and Arad also. Okay, Arad is also neighbor to Cebu and Ordia also. And after that, Arad is already visited. So Ordia is 140 and 151. How? Cebu to Ordia is 151 and the heuristic value of Ordia. Here. It's not clear, but 150 plus 151 suppose 150 plus 381. Okay, so 671. After that, Fagaras, for Fagaras, Cebu to Fagaras is 99, but the cost is already there, like 140 is already here, which we like Arad to Cebu is 140, then Cebu to Fagaras 99. So total cost will be 140 plus 99. That is here 140 plus 99, 239. And the heuristic cost of Fagaras is here 176. So 239 plus 176, 415. So for Reminku the cost will be 140 plus 80. Then heuristic will be, where is Reminku? Here 193. So yeah, 140, 80, 220, then 193, 413. So among these, what's the lowest? Lowest is 413. So explore Riminko. While exploring Riminko, we have three neighbors. One is already Sibiu, the other is Kralova and Pitesti. So let's explore those. Okay, expanding Riminko. Let's just put this as side by side. Okay. Okay. Okay, this is the map and this is the calculation. Okay, we are at Riminko. Riminko, Sibiu already visited. So Karyova, the cost to reach Karyova is 140, 80, and 145. Maybe this is 146. So 220 plus 146, 360, and the heuristic value of Karyova is 160. So 366, 160, 526, and P-test will be 140, 80, 97. So that's total 317, and heuristic value of p-test is 100. So total is 417. Okay, what's the minimum? P-test. So explore P-test. So while exploring P-test, there are only three nodes. That's already Riminka, Karlova, and Bucharest. So Riminko already visited, Karyova already visited. So what's the new node? Bucharest. To reach Bucharest, we have 140, 80, 97, 101. So total 418. And the heuristic value of Bucharest is 0 because that's our goal node. Okay, so 418 plus 0, 418, and we have reached our goal. So what's the path? Path is Arad, Sibiu, Riminko, Pitesti, Bucharest, and the cost is 4 418. So maybe I have this code here. This is the greedy search. What's the Esther search? Here, Esther search. Um, hmm. For the for this Romanian map, I have tried to implement the code using class. Okay, you can look at this. If you can't understand this one, just ask Gemini. It will simplify this code. But let's just run this one. You can see. Okay, uh, this will show the cost and path. Okay, which we have here. Okay, so Arad to Arad 0, and then CBU 140, then Riminku 220, then PTST 317, then we reach Bucharest at cost 418. So this is the code for Romanian map, and there's another example for a star search, like the previous graph using this one and these heuristics values. So we have code for, I have simplified the Astar code version for this graph, like you can see A, B, 30, C, 24. Okay, this is the simplified version. Let's just first calculate it manually, then we'll look at the code. So as we go with Star function, like formula is g of n plus h of n. So the goal node is L and the source node is A. So now we start at A. So g of A is 0 because the cost of going A to A is 0. So f of A will be 0 plus 95. 95 is here, the heuristic cost. Now we explore B and C. For B, the cost will be 30 plus 105. Okay, is here 105, 135. And for C, 24 plus 65. Okay, 65, 89. Okay, 24 is the cost of path. So after that, what's the minimum here? The minimum here is 89. So explore C. While exploring C, there are two nodes, F and I. There are also A, but A already visited, so we are not considering that. So F and I, the cost for F is 24 plus 19. How? This is 24, so this is 19. So 88. And for plus 45, 45 is this one, the heuristic cost. Okay, 88. For f of I, 24 plus 25 here, 24 plus 25 I, then heuristic is 38. So plus 38, 87. So the minimum now is, like we have 135 initially, then we explored B and C, and from B and C, we explored C. So while exploring C, we found 88 and 87. So currently we are comparing 135, 88, 87. The minimum is 87, so we explore I. So while exploring I, there is only one node K. So f of k 24, 25, 18. Here the path cost 24, 25, 18, and the heuristic value of k is 17, which will also be added here. 17, that's 100. Okay, so currently 135, 88, 100. Okay, so 188, which is f of f, we explore that one. So while exploring that one, we get only j. So to reach j, the cost will be 24, 19, and 24. So here 24, 19, 24, and the 15 is the heuristic value. So output is 82. So now the minimum 135, 100, and 82. So 82 is minimum. So explore j. While exploring J, there we reach to our goal node by like the cost is 16. Okay, so the total cost will be 24, 19, 24, 16. Okay, here 24, 19, 24, 16, and the heuristic value for goal node is 0. So output A is 83. So final path is A, C, F, G, sorry J, and L. Okay, this is the final path, and the total cost is 83. Okay, 24, 19, 24, 16, 83. This is the final path and this is the cost. So if we look at the code now, um, okay, here this is the aster search function. This is the main function. In the main function we have the graph, then have the heuristics values, and after that we are calling the aster search function and printing the path. So in the aster search, initially we have two like one array open list and a closed list set. Then we are exploring this name as a start node and parent to none, and g is equals to 0, like cost is initially 0. Then the heuristics value of the start node and heuristics value of the final node. Okay, that's f. Now open list, until the open list is not empty, we are exploring each node. We are considering the cost of current node, and we are also adding the heuristic value. Then we are doing the summation f. Then we are exploring the neighbor again. So if neighbor node and f node greater the neighbor node of f, like the cost f is greater than the neighbor node of f, then continue, like it's not minimum. But if it is, then we stop and return here. Okay, if the current node is cost is lowest and then the goal node is also reached, we will return the path from here, this function. Okay, so this is for updating neighbor in the open list. Okay, so if we run this code, we have passed the parameters as source node is A and goal node is L. So as you can see, A to C to I to K to L. So total, this is the path and cost, and that's 83. Okay, that's 83, similar to this one. So this is like Aster search and Aster search and greedy search code. Maybe I have missed another one, which is 8 puzzle. Okay, 8 puzzle problem is from. It's like is it here? Maybe not. It's from the uninformed search or here. Mm, maybe 8 puzzle is from. Yeah, eight puzzle. I've missed the eight puzzle. So eight puzzle problem is you are given a matrix like this, like 2 8 3 1 6 4 7 blank space 5. Maybe you have played game like this. We have to like sort in a order of this. So there will be added the initial state and the goal state too. The goal state is you move the space to the middle of the matrix. Okay, it will be sorted like this: 1 2 3 4 5 6 7 8, then space. Okay, this is the eight puzzle problem. But there's just code here. Eight puzzle. In this problem, uh, the given array will be like this. Okay, 1 2 3 4 space 5 7 8 6, and the goal node is this. We need to put the space at the end of the matrix. Okay, I have mentioned it here. The start array will be, matrix is like this, and the goal matrix is like this. Now we are calling the solve it puzzle problem function using the start and goal array. And so let's just look at this function. Eight puzzle, solve eight puzzle, start and goal. So we are like adding the neighbors in the queue, and we have an empty visited arrays. And while queue is true, we are like current state and path. After that, current state is equal to like map or not, then returning the path and current state. So if current state tuple is visited, then continue. Continue means it will like start the loop again. Otherwise it will add the current state to the visited. Okay, if child state generate children, like generate children is another function here. Generate children, for generate children, this is like this is array, like we need to move the space, like so we need to move this blank space to up and down, like so we are using this array to do that calculation. Okay, find the blank space, this is another function here. So this will just search for the blank space. Okay, dash, this is the blank space, and it will return it here, the position of xy. Then it will do the calculation like x plus dx and y plus dy to see if this position is our goal state is not or not. Okay, so if the it is true, then it will be returned here. Then the state and path will be added to the queue. If there is no solution, it will return none. But if there is solution, um, the solution will be returned. Okay, so return path plus current state. Okay, this will be returned. When this will be returned, it will be stored in this solution. So if solution is true, print solution found, and the state by row and column will be printed. Otherwise it will be printed no solution found. So if we run this program, we get this one. Okay, from middle, it first go to the right side, then after that it go down and reach the goal state. Okay, so the only task is moving the blank space to its desired position, moving the blank space to its desired position. Okay, that's the eight puzzle problem. And that's a lot for like single lecture, but maybe you can take some time and look at this course, and maybe this exercise files is also added in the column already. There is another task for you was like genetic algorithm, but I don't think we can cover that in 20 minutes, so we will cover that in the next lab. For this I'm giving you some like 2 minutes, look at the code, and if you have any question you can ask. Okay, just 2 minutes. This is the attendance sheet. You give your attendance on the second page of this sheet. If you look at the bottom, you can see there is section 2. I will share the exercise answer to the WhatsApp group. I just need to edit this a bit, so I will update it today. And if you have no more questions, we can end it here. Thank you, everyone. Assalamu alaikum.
Thank you, madam.